Alright, so this video is meant for my geometry students. We have a quiz coming up on Tuesday, or Wednesday for my white group, and these are 8 problems that are supposed to be beneficial and help you prepare for that quiz on Tuesday. Okay, here's problem 1. It says, write the ratio of the first measurement to the second measurement. And it says, the length of the tennis court is 26 yards, the length of the tennis table is 9 feet. So I'm going to write a ratio, 26 yards over 9 feet. But we cannot reduce this because they're not in the same units. So we must convert. Now the conversion from yards to feet, there are 3 feet in 1 yard. And I want to go from big to small. So big to small would be yards to feet. So I'm going to take my measurement that's in yards and change it to feet. Alright? So if there are 3 feet in 1 yard, then how many feet are in 26 yards? Well, I'm going to take this and multiply by 26 on both sides. So 3 times 26, I believe, is something like 78. 3 times 26 is 78. Very good. That's how many feet are in 26 yards. So this ratio is going to change to 78 feet over 9 feet. And this I will simplify. Alright, so the feet cancel, and I think each is divisible by 3. And when I divide by 3, 3 goes into 78. 78 divided by 3 is 26. 9 divided by 3 is 3. And I believe that is the smallest reduction I can make. 26 to 3 is that ratio. Convert big to small. If you need a unit conversion on a quiz, just let me know. I can give it to you. Alright, the next problem here says a baseball team played 154 regular season games. The ratio of the number of games they won to the number of games they lost was 5 to 2. How many games did they win? How many games did they lose? Okay, so they give us this ratio of wins to losses. This ratio is 5 to 2. Okay? Well, if they play a total number of 154 games, okay, then, the ratio of wins to losses is 5 to 2. Change this ratio of 5 to 2, and I'll write it in colon form. Change it to 5x to 2x. Because we really don't know how many losses, how many wins they had, but we know the ratio. So we can multiply each of those numbers in the ratio by some multiplier to give us the actual number of games won and lost. So 5x is the wins, 2x is the number of losses. Add them together to get your total games. And the total games you played was 154. 5x and 2x is 7x, and divide by 7. We get 22. So this multiplier is 22. Okay? So 5x represents the number of wins. 5x, which is 5 times 22. 5 times 22 is 110. That's how many wins they had. 2x is the number of losses. 2 times 22, that is 44 losses. And if you add 110 and 44, you get 154. And if I were to reduce both of those numbers by the factor of 22, you would get 5 to 2. And there's a ratio problem multiplying both by x. Alright, next problem here, we're going to solve this proportion. It says 5 over x plus 2 equals 3 over x plus 1. First thing I will do is I will put parentheses around these binomials so that I make sure I distribute. Do not make that mistake. And now I cross multiply. 5 times x plus 1 equals x plus 2 times 3. I'm going to put the 3 first. 3 times x plus 2. We go ahead and distribute the 5, so we get 5x plus 5, and we distribute the 3, 3x plus 6. I'm going to subtract 3x from both sides to combine the x's to give us 2x plus 5 equals 6. I'm going to subtract 5 on both sides to continue to try to get x by itself. 2x equals 1, and divide by 2. And what do I get? I get x is exactly a half, or 0.5. That's how you solve a proportion. Alright, next problem here. It says determine whether the polygons are similar. If so, write a similarity statement and give the scale factor. If not, explain. Okay? So this problem right here is from section 7.2, where you don't know the triangle ideas. Okay, so let's just take a look at understanding similarity. Similarity means you have corresponding angles that are the same and corresponding sides that are proportional. Okay, so we're not going to use one of the three ways. Not going to use one of the three ways here. If I look at this picture, they're not oriented the same way. I'm going to take this smaller triangle and redraw it down here. The bigger triangle I'm going to keep, but the smaller triangle I'm going to redraw right here. That's the right angle, that's P. QP is the shorter side, and PR is the longer side. QR is 17, PQ is 8, and PR is 15. Okay, so now I am oriented the right way. Alright, so now what I'm going to do is I'm going to first look at the angles. Okay, and I did not mark the angles again. So Q has a single marking, R has a double marking. So are the corresponding angles congruent? And I'm going to spell it out for you. We look at angle K. Angle K is congruent to angle Q. We look at angle J. Angle J is congruent to angle P, because they're right angles. And angle L. Angle L is congruent to angle R, because they're double marked. So yes, we do have corresponding angles congruent. So now, are the corresponding sides proportional? Okay, well, small to small. Let's go up with this. 16 is the smallest, corresponds with 8. 30 is the next biggest, corresponds with 15. 34 is the largest, corresponds with 17. There are the three sides in order. So I reduce 2, 2, 2. All come out to be the same simplified answer, 2, 2 to 1, whatever you want to say. So corresponding sides are proportional. Check. Are these similar? Yes, they are. Let's write a similarity statement. Okay, I'm going to name the first one triangle K. I guess JKL. Is that JKL? Similar to triangle. So J is the right angle, so P is the right angle. Up the smaller side, so up to Q, and then over to R. There is the similarity statement. And then I want the scale factor. Well, the scale factor is a side from JK over a JKL over a side from PQR. Just take this first one. 16 over 8, simplified, that's 2 to 1. There's your scale factor. Alright, next. Alright, so we have the polygons are similar. Find the value of each variable. These are a pair of overlapping triangles. So what I'm going to actually do is I'm going to draw them separate. Alright, I always think it's easiest to draw them separate. So I'm going to draw this picture right here. This is Y, this is X, and that's 5. And I'm going to draw the other triangle right here. This is 6, that's 8, and this is 10. And the question is, what are X and what are Y? Well, we need to use proportions to find X and Y. So let's start with X. I'll use a different color. X is orange. X corresponds to the side that is 8. Equal to. We now have to use the sides that we know both measurements. 5 and 10, we know both measurements. They are corresponding sides. Use those two sides. Now, X came from the smaller triangle, so 5 must come first from the smaller triangle. 5 over 10. Cross multiply. 10x equals 40. Divide by 10. And x is 4. Now, to find y. Y corresponds with 6. Again, use the sides you know the measures of. 5 and 10. Y comes from the smaller triangle. Go back to the smaller triangle. 5 over 10. 10 times y is 10y. 6 times 5 is 30. Divide both sides by 10. Y is 3. And there's x and y in this triangle. Alright, next problem. It says, the design for a mural is 16 inches wide and 9 inches high. What are the dimensions of the largest possible complete mural that can be painted on a wall that is 24 feet wide and 14 feet high? Okay, so again, this is one of those problems where we're taking a picture, 16 inches wide, a design, 9 inches high, 16 inches wide, and we want to put it in this space, a wall. Okay, in this wall, and I'm sorry, I'm going to put it in here, is 24 feet wide and 14 feet high. So there's only two options. Either the height fills the height or the width fills the width. And that's what we're trying to figure out. Which one is which? So we do two options. First, fill the height. Now, the design stays in the ratio of 9 inches to 16 inches. Okay? Over here, though, if we're going to fill the height, that means the 9 fills the entire 14 feet. And the question is, what then does our width become? Cross multiply. 9 times x is 9x. 16 times 14 is 224. Divide by 9, divide by 9. In this instance, x comes out to be 24.8 repeated. Okay? Well, that would mean that your new dimensions would be 14 feet by 24.8 repeated feet. Well, you only have 24 feet. This is too big. So now we have to try the other one. Fill the width. So again, the design remains in this 9 inches to 16 inches ratio. But now instead of the height being filled, we're going to fill the width. This width is going to fill the entire 24 feet. And we need to figure out what would the height then become. Cross multiply. 9 times 24, 216. 16 times x, 16x. Divide both sides by 16. We get an x value of 13.5. So with this dimensions, the height would be 13.5 feet by that filled width of 24 feet. And 13.5 is less than 14. Hey, there's your dimensions. That's the biggest picture you can make. Alright, number 7 here. Determine whether the triangles are similar. If so, write a similarity statement and name the postulate or theorem you used. If not, explain. So here is where we're going to use our triangle similarity ideas. Angle, similarity, side, angle, side, similarity, side, 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 similarity. First thing I'm going to do is I'm going to make the pictures look oriented the same way. Okay? I see a right angle, so I'm going to take the top picture and flip it around. Now, the right angle is at A. Now, this is the shorter side 6, so the shorter side must be corresponding. Well, that's 6, and that would be A to N. This leaves the last side to be D, so then that side's 8. So now I have two figures that are oriented the same way. Now, I look at what I'm given. An angle and the sides around it. So I'm thinking, remember we talked about think, side angle, side similarity. That's what I'm thinking. So to do that, the angles have to be congruent. Well, they are. Angle A is congruent to angle P. Check. So now, what about the sides around the angle? Well, I'm going to pick the smaller side from this triangle, 6. It corresponds to the smaller side over here, 6. Come back to this triangle down here, 8 is the other side. Corresponds to the other side, 10, which is bigger. And we just simplify. 6 over 6 is 1. 8 divided by 10 is 0.8. They're not the same. That means the sides are not proportional, which means these are not similar triangles. So side angle side does not work. These triangles are not similar. Alright, a last problem here, another triangle similarity problem. Are these two triangles similar? So let's first, I'm going to take this smaller triangle and redraw it like this. Alright, so just draw a little small mini-me picture. Let's see. So the smallest side is AC. That means that GH has to correspond, but I flipped it upside down. So I think G is going to be down here, and H is up here. That's the smallest side. Then C to B is the next biggest side. Well, that would be G to K. Well, if G is here, there's K. So here is 9, here is 11, and here's 12. So now the big triangle and the small triangle correspond. All three sides are given, so think side, 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 similarity. And to do that, we just relate the sides and ratios based off of size. If I take a look at this big triangle first, the smallest side is 18. It corresponds to the smallest side down here of 9. Keep going. The next biggest, 22, corresponds to 11. Keep going. The next biggest, 24, corresponds to 12. Simplify. 2 equals 2 equals 2. Hey, they're all the same ratio. These sides are proportional, which means these triangles are similar. Write a similarity statement. Triangle ABC is similar to ABC. Since I oriented it the right way, HKG. I can easily get the orientation, easily get the correspondence. There we go, and this is by side, 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 similarity. And there we go. There's your quiz. Hopefully you prepare well, do your note cards, bring your notes, and you have a great quiz to contribute to your third quarter grade. Alright, thanks for watching. We'll see you on Tuesday.